Okay, welcome to section 12.5. Today we're going to talk about adding and subtracting radicals. You have to have the same thing under the radicals in order to add or subtract their coefficients. Works just like terms. I mean exactly like terms. Think of these radicals as letters and you'll be golden. So for this one right here, the coefficient is always the number in front of the radical. We don't change what's underneath the radical, just like when you add x plus x, you don't get x squared. You get 2 of those x's. It's the same way here. We have 1, it's not written, but it's there, 1 square root of 3 plus 4 square roots of 3 gives us a total of 5 square roots of 3. Just like letters, whatever you had to have in the beginning is what you have to end up with at the end. Same thing here. Even though there's not a 1 written here, we know that there's 1 there. So 1 square root of 3 minus 4 square roots of 3 means you're going to be left with negative 3 square roots of 3. It's okay to have a negative on the outside. It's not okay to have one on the inside. Right here, we have negative square root of 10 plus the square root of 7 minus 3 square roots of 7. Are these two like terms? No, they don't have the same thing underneath. So just like with like terms, if they're not the same, you can't combine them. These two are like terms, so they can be combined. This one off by itself, we can't get rid of it because it's still a part of our problem, but it's not a like term, so we're not going to combine it with the others. And this gives us the square root of 7 minus 3 square roots of 7, so that's going to give me negative 2 square roots of 7, because 1 minus 3 is negative 2. Now there's nothing I can do with this because they are not like terms. So this is done. Think of this as an x and that as a y, and you can't add and subtract those. You could multiply them, but that's not what they said. They wanted you to add and subtract them. You can't do that. Sometimes you can't just say they're not like terms. Sometimes they're going to ask you to add these, and you're going to look at them and you're going to say, no, they're not like, we're all good, let's walk away. That's not correct, because these can be simplified. Over there, they couldn't be simplified. You can't simplify the square root of 10 because there's no perfect square inside of that. But here, this is 3 times 5 times 5. 2 on the inside make 1 on the outside. So that's like 5 square roots of 3. And then here, that's like 3 times 3 times 3. 2 on the inside make 1 on the outside. 2 times 3 is 6 square roots of 3. And here, we have 2 times 2 times 3. 2 on the inside make 1 on the outside. So that's minus 2 square roots of 3. Now, they are like terms. So now, you have to go ahead and combine them. 5 plus 6 is 11, minus 2 is 9 square roots of 3. Your question should be, how do I know when I need to look for it and when I don't? Always look for it. Then you don't have to worry about it. Always look for it. Because chances are, if we gave you that problem, we mean for you to find something. Especially if none of them are the same. Usually at least 2 are going to be the same, if not all of them. So you should always look for it. Let's have you try a few. Have you try that one, and then this one. So go ahead and pause it and try those two, and we'll see how you do. Okay? I hope you looked at that and you saw right away that it was a perfect square. And so that would give you 3 times 6 square roots of A, which is 18 square roots of A. And then here, I'm hoping you saw right away that that was a perfect square as well. So that gives you 10 square roots of A. And then here, I'm hoping you saw that that was a perfect square as well. So that's 2 times 8 square roots of A minus 16 square roots of A. And then you can come back and combine them. 18 plus 10 is 28, minus 16 is 12, I think. So that leaves you with 12 square roots of A. For this one, they had pretty numbers as well. But did you remember to take out of that one, or did you just say they were all the same? So that's 3x times 5, and 2 goes into 3 another time, square root of x, which on the outside leaves me with 15x squared, square roots of x, minus, the 4 can come out as a 2, take an x out of there, which leaves me with 2 x's on the outside and 1 x on the inside, plus, I have 3x already on the outside. That's going to give me a 3, plus this 2 goes into there one time with 1 left over. So that gives me 3 squared, which we know is 9, so I'm going to go ahead and write 9. X squared, square roots of x. Now, not only do my radicals all have to be the same, but because we're doing like terms and there are letters outside, they have to all be the same too in order for us to add and subtract those numbers in front. So 15x squared square root of x minus 2x squared square root of x is 13x squared square root of x, plus 9 is 22 x squared square root of x. That one was a little difficult, but I bet you could do it. I got faith in you. I'm sure you rocked it. Let's talk homework and classwork. I don't know where I'm going to talk it at. Used up a whole bunch of space. Homework. Oh, I give classwork first. Hold on. Classwork. On page 510. Numbers 1, 7, 11, 17, 21, 27. Homework. Same page. Numbers 5, 9, 15, 19, 23, 25, 33. There you go. I fit it in. And I'll see you in a couple of days.